All right, question 14, year 2016. All right, so Theresa, a student, was employed as a guide for a cultural tour. So she decided to use graph theory to plan out the walking tour. So you are given like A until K is the points of interest to be visited. Then after that, A just represent the direct routes. Okay, so use Euler's formula to verify that the network is connected. Okay, so you can see for this question, it's a bit special because normally we use Euler's rule to verify that the graph is planar, right? Okay, so why is it connected? So if you remember for Euler's rule, right, the idea for Euler's rule is actually to check a planar connected graph. Sorry, in the other way, it's supposed to be like connected planar graph. So why is that so? Because if let's say the graph is not connected, right, you can imagine that I can add as many as isolated vertex that I want. But as I add isolated vertex, there is no faces, there is no edges added. So you can see that if the graph is disconnected, then you wouldn't be able to verify the Euler's rule, because you can imagine that for V plus F minus E equals to 2, right? You can keep on adding the V, but then the F and E doesn't change. Then in this case, you wouldn't be able to get 2 anymore. So that's why you need to remember that for Euler's rule, it will apply for the situation that the graph is planar and at the same time, it must be connected as well. Okay, so that's why it's connected planar graph when you look at your notes. Okay, so use Euler's rule to verify. So same thing. So V equal to, so you have A until K. In this case, we have total of 11. So number of edges. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17. So that's why there's 17 edges. Then number of faces, 1, 2, 3, 4, 5, 6, 7, 8. So faces equals to 8. Okay, then after that, same thing, V plus F minus E. Then you have 11 plus 8 minus E. Sorry, minus E, which is 17. So you can see 19 minus 17, you get 2. So that's why you verify that this is correct. Okay, so Theresa planned to take the group on a close walk. So explain the meaning for the close walk. Okay, so you can see this is a one mark question. Normally, they don't ask for the meaning for walk lah. The keyword here is actually to explain what is that mean by a close one. Okay, so that's why a close walk is a walk that starts and ends at the same vertex. Okay, so that's why a walk which, okay, you can say starts and finish, or you can say starts and ends at the same vertex. Okay, so she also started the walk. Sorry, she also stated that the walk would qualify as a Hamiltonian cycle. So state 2 properties that makes a walk a Hamiltonian cycle. Okay, so when you look at this, okay, so yeah, they didn't refer to any of the walk last, so which means that you are just going to write down what a Hamiltonian cycle is. Okay, so you know that for Hamiltonian cycle, the idea is that you need to include all the vertices once, right? Then you need to start and end at the same vertices. So you just state out the 2 of the properties. Okay, so a walk. Sorry for that. You see, don't know what happened to my pen today. Okay, a walk which includes all vertices once. Okay, then after that, you also need to start, because it's cycle, so that's why you need to start and end at the same vertex. Okay, so mention one of it, give you 1 mark. Okay, so given that this walk has to start at G, which is the Trinity College, so mark the Hamiltonian cycle on the graph on the network below. Okay, so same thing, this is a Hamiltonian cycle, so you can only try and error. So just try to draw out a path that able to, you know, go through all the vertices once, then you go and start ends at G. Okay, so that's why I think the one way that you can go easy is go to I first, because this is the one that is quite obvious already. Okay, then after that, you can look at the situation that because you can only pass through all the edges once, then there's no point that you go to F first, because if you go to F first, then later you want to go to B to A, then it will be a bit difficult. So that's why we go A first, then go to B. So you can see that if you straight away move on for D, then later you cannot go to F. So that's why we will go this way. Then now you are able to include all the vertices and you start and end at G. Okay, so that's answer for part D. All right, so that's it for this question.